Hello, my name is Zave Perry. I'm here to just show off my data structure tutorial that I've put together to help others learn and myself learn more about these different data structures in Python. And so I put together this data structure tutorial on GitHub, and I have this README file to find the welcome page. You'll go here and it'll show up all the different tutorials that I created. The first one being the stack. And so for this one, I tried to teach the basics and then move up a little bit more in complexity with each step. And so I just explained the basic stack, how to add to it really fast and what it kind of looks like, and how the last is removed before the first item added. And that is demonstrated by this bucket visualization here, which I like for my own learning. I've seen it before and helped me a lot, so I knew it would help others too. Um, and then, yeah, for the nested functions, I just made this basic thing that calls functions even itself, and it shows how they're all added into the bucket one by one and removed as each step goes on in that little table. Um, then I talked about the append, pop methods, both of them together, and then just an example to understand it, made a balanced equation with some parentheses. This just goes through to make sure that it is balanced. And then this one even has numbers and things that can be like an actual equation, and it will check if that's balanced as well. Let you know if it's true or false. And finally, there was a problem to solve. You can add text, undo text, and quit text. So it's kind of like you type something, hit Control Z if it's a mistake, and do that um, with a stack. And so for the test cases I did once upon a time, there was a mystical wizard named Steven, and then you can undo it and whatever. Just had a little bit of fun with there. And also for learning, even though they learned about a stack in this tutorial, I mentioned some things that I thought were useful to solve it. So like slicing, list slicing, or the starts with function. Um, it links to the solution with how I solved it so that they can compare their answer to mine. Okay, and then, so yeah, that's the first one. The next one, just go back to the welcome page, was the linked list. On here, pretty similar, had some more visuals to, like this one explains a doubly linked list, showed the performance to show why we use linked lists, because they are a little bit more difficult to understand, but you can see why they're better, bolded the ones that have the better performance there. I just showed all the different functions and code to make the classes for both of these, for the nodes and for the linked list, that they'll be able to need to finish the problem at the bottom. So class for the node, obviously, did that, just to initiate it, insert head and tail stuff. Here's showing how to insert something into the middle of a list. Here's the functions to describe that, print the list, and then here's the example. Just did like a grocery list, and the test one was very similar. It's just to make the same pretty much thing, but with a playlist instead. Back to the welcome page, and then the last one was the trees. This one, trees use recursion, they use special methods. And so I also talked about those within this because as I'm explaining these different data structures, I'm just trying to cover anything that they use to give a basic understanding of it. Talked about performance again, how when it's balanced, it's going to be O log of n instead of just O of n if it's unbalanced like this example. Recursion, let's see. I labeled like where I used recursion for the first time to make these functions, and I kind of defined it down here for more understanding. I explained why there's this underscore before the insert. Um, oh yeah, like I said, I explained the special methods like contains. There's also iter, there's init, there's reversed. Explained how all of those work. Let's see. Yeah, finding the height, and then yeah, the example just populate a tree, print it out, and then the problem to solve, I did a factor tree. So you'll pass in a number, and it'll give you all the factors that make that up. And to understand more of the functions, because I gave them all to the user. Oh, and for the tree and for the linked list, I have this link to find all the functions, just so that they can have access to them and not have to like copy and paste every little one of these snippets. Um, let's see. Yeah, so anyway, I made this here so that you plug in a number and then it'll show us the factors. And obviously there's going to be repeats in here. The original insert function does not allow repeats or duplicates. And so I instructed them to edit the insert function so that it does allow duplicates in the binary search tree. And yeah, so that's how I explain these three data structures. I have my contact here if anyone has questions, but thanks so much and hope you can learn something from it.